All right, thank you. We're talking about food initiation response to early season water stress, and my collaborators on this are Dr. Ron Sorensen and Marshall Lamb here at the National Peanut Lab, and then Chris Pallone and Leticia Moreno over at the Tifton campus of the University of Georgia. And this really kind of follows right along with what Dr. Pallone was talking about in her presentation. Let's see. There we go. One of the reasons we're looking at fruit initiation is that we have the irrigation decision support system called Irrigator Pro for peanuts. And part of that is we use daily water use estimates to forecast when a grower should irrigate. And you can see kind of from this graph that the slope of the line is very slow, up to about 45 to 50 days, or up to that fruit initiation date. And then at that point, the slope of the line or the daily water use increases dramatically based on, and these are tied to the phenology of the plant. To give you a little bit better picture of that, I broke it down into our growth stages that we use in Irrigator Pro. And basically you can see that we use about 1.8 millimeters per day as our estimate of daily water use up to the point of fruit initiation. And then once we hit the fruit initiation date, daily water use estimates increase to about 5 millimeters per day, and then get into the pod fill and addition and maturation, in which jumps up to about 7 millimeters per day. The main point of this, though, is that you look at those event beginning and ending dates. It all hinges on our estimate of the fruit initiation date. So this is a critical date that growers need to make a field observation and confirm that event in their field, so that they can get accurate projections of when they should irrigate. Jim Davidson, when he developed this program, he looked at and defined fruit initiation date as the date of the first flush of blooms, and that was, he put a number on it of when we had an average of 10 blooms per plant. Of course, blooms come and go in about a day, so it's hard to count those on a plant. So he came up with a way to calculate that fruit initiation date based on the average number of healthy underground fruit components, which are defined as the pins, pegs, and pods. And so basically we use this formula in Irrigator Pro to estimate the fruit initiation date. So what we did in this particular study is we used AUNPL-17 planted in 2 of our rainout shelters at the National Peanut Lab, planted them at 6 seed per foot on a 36-inch row spacing. We applied at-plant applications of 4-8, and then we did a pre-emergence herbicide application after we covered the seed, and then we immediately irrigated after planting to activate the herbicide and then to ensure that we had uniform germination. After that, we put the roofs on so that they would automatically close whenever we had a rainfall event, and so that we could control the irrigation or water applied to each of these plots. We divided the 2 plots that we were using into a front half and back half, and then that's how we applied our irrigation treatments. Our control was what we use in Irrigator Pro, which is basically we trigger at about 40 kilopascals of soil water tension. And then treatment 1, we allowed the average soil water potential to decrease to 100 kilopascals. And then after that, we irrigated according to the normal Irrigator Pro recommendations. Treatment 2, we did 2 cycles of the 100 kilopascals to trigger irrigation, And then treatment 3, we allowed the soil water tension to decrease or increase to 200 kilopascals. And then we irrigated according to normal, to the Irrigator Pro threshold of 40 kilopascals. I might say that Irrigator Pro typically does not recommend irrigation typically for at least the first 30 days of growth. And so the data collection that we did during this study was that we used Decagon MPS2 soil water potential sensors at 20 and 41 centimeters in the front and rear halves of each plot. We recorded that soil water potential every 2 hours with the data logger throughout the growing period. And then each day at 7 a.m., we went out and took those readings, averaged the readings for each of our treatments, and then irrigated accordingly. To measure fruiting, beginning about 30 days after planting, every Monday, Wednesday, Friday, we went out and pulled up 5 plants out of each plot. We counted the number of flowers, pins, pegs, and pods on each plant. And then we averaged the total number of pins, pegs, and pods and substituted that into the equation and calculated fruit initiation date for each sampling date that we collected samples. After we reached a consistent date for fruit initiation, we stopped sampling, which was somewhere around 60 days after planting. And then we allowed the plots to go to final yield and just took one yield for each plot. So there's no statistical data to go with those yields. Here's a graph of what we saw of terms of total fruit indicators per plant. And you can see there's, in response to some of the watering activity, that we would get a peak of, and it looks like a couple of what I would say venturing into, getting fruit initiation. For instance, in the control, we crossed 10 fruit indicators per plant somewhere around 43 days. And then the next sampling period, we reached a maximum of 15 fruit indicators. But then a sampling later on at about 48 days, we were down back to about 6 fruit indicators. So was it sampling? Was it what we actually occurred? But anyway, you can see those sort of inflections for just about all of the treatments, with the exception of for the treatment where we went to 200 kilopascals. So what we did is we averaged the fruit initiation date for all sample dates, and basically we saw that there was no difference between the fruit initiation dates that we calculated in the mean. And it was either June 30th or July 1st for this 1 year. However, the interesting thing to me was that the standard deviation decreased as we induced some water stress. And we had about a 3-day standard deviation for the control. And then for all of the early season stress, we had about a plus or minus a day or less for our standard deviation. So sort of in summary of this then, since this is just a single year of data, we are repeating that test again this year in our rainout shelters. But based on the 2020 data, and this kind of goes along with what maybe Dr. Pallone's presentation was showing, was that we had no measurable effect on average fruit initiation date, but we did see reduced variability of that fruit initiation date in response to early season drought stress. So based on just 1 year, it seems that our recommendation for irrigating only to promote uniform emergence during the first 30 to 45 days in Irrigator Pro continues to be valid, at least for the AUNPL 17 and possibly other cultivars. But this does verify, at least on a 1-year basis, of what we're doing in Irrigator Pro. So with that, I'll be glad to answer any sort of questions that you may have.
Let's see, Chris, I don't think we've got a question that I can see
Okay.
in here. So I think we'll move on to our next presentation. We're just a touch behind. Thanks a lot
Okay.
for being involved today. Thanks a lot.
Thank you.
Enjoyed it.